Hello PH 301 students, welcome back to our second lecture of this course titled Introduction to Special Relativity. This is based off chapter 28 of our textbook. As I mentioned in our introductory lecture, the theory of special relativity was developed by the German physicist Albert Einstein back in the year 1905. This theory relates to the limits placed on an object's speed and the consequences of these limitations. So naturally, we ask the question, how fast can an object travel? Is it possible to reach a speed, let's say, of infinity? And in special relativity, the answer to that question is no, we cannot reach infinite speed. And in fact, there is a limit to how fast an object can travel. And these limitations have changed the way we think about space and time. First of all, what exactly is relativity? To put it simply, relativity is the study of how different observers measure the same event. And although Albert Einstein came up with the special theory of relativity, he wasn't the first person to study relativity. In fact, it was Isaac Newton and Galileo Galilei who came up with the concepts of classical relativity. And it was Einstein that came up with the more accurate modern model of relativity that we call special theory of relativity. Special relativity, as proposed in 1905, deals with observers that travel at a constant velocity. General relativity, which was proposed in 1915, deals with observers who are accelerating. The important thing to note before we really dive into the study of special relativity is that it has been verified by experiment, so that you know that we are going to be studying something that is not made up, it is not magic. Actually, it is really something based off the physical universe. And this applies to the world in which we live in. In fact, there are many applications of special relativity in our modern world, including GPS or Global Positioning System, which is very useful for airplane navigation, car maps, and satellites. Another thing to note is that although classical relativity as well as classical mechanics, which have been covered in previous courses, they may not be as accurate as special relativity and quantum mechanics, which are the two topics that we will be covering in this course. However, the classical ideas are useful for studying large and slow-moving objects. However, when studying objects at the microscopic level and moving at speeds greater than 1% of the speed of light, then the more modern theories of special relativity and quantum mechanics should be used instead of the classical ideas. So this is a very short intro. We now begin our deep dive into the special theory of relativity, starting with Einstein's postulates. I'll see you guys in the next lecture.